Welcome everyone to second day of the course. So yesterday we talked all about what data is, what a data professional is, and how does a data professional think about a problem, and also how a good data professional looks like, what sort of characteristics you can find in a good data professional. Today we will start to get into the actual workflow of a data professional. So when you start a data project, what is the first thing that you will do in any data project? Does anyone want to take a guess? What will be the first thing you will do?
Data acquisition.
Yeah, data acquisition. Because in order to do any analysis, you need data. So you need to get that data from somewhere. And the process of getting that data from somewhere, it's called data acquisition. And today we will talk all about data acquisition. And data acquisition always comes in hand with data storage. Because if you pull data from somewhere, you have to put it somewhere else. Like you cannot keep holding it, right? So when you get something from somewhere, you have to put it as well. And the process of putting the data somewhere is data storage. So you get the data from somewhere, you will put it somewhere else so that you can do your analysis. Sometimes you probably don't need to make a copy and then you can maybe do your analysis on the source itself. But most of the time, you probably will be getting the data from somewhere, maybe creating a copy, and then you will doing your analysis on there. So that's what we will focus on today. We will learn all about where will we get our data from, what are the different methods of getting the data, and how we can store it so that it is most efficient for our analysis. Because the purpose of storing the data is not just for the sake of storing it. We're trying to store that data so that we can facilitate our later analysis. For example, if we are planning to do our analysis in Excel, then it's probably fine to save our data as CSV files and all those kind of things. But if our final destination is different, like if it is Power BI, maybe it's still fine to be CSV, but there could be some other alternatives if we want it to be more efficient, if we want it to be easily accessible, or all those different things. And that's definitely what we will deep dive into today. Let's jump into today's topic. So I can go to continue and it will take me to the course player. Data acquisition, as the name suggests, is the foundational step in the data analytics. It involves collecting, and sometimes you probably need to digitize it. Maybe the data that you are looking for is on the paper, and then you cannot analyze the data that's on paper, so you probably need to digitize it. And that's also the data acquisition process. And sometimes it could be archiving, depending on whatever it is. And sometimes the data might not be there. So you probably need to do your surveys, or you probably need to do something else to first collect that data in the first place so that you can do that analysis. So depending on whether that data exists or not, whether that data is in digital form or not, it could mean just more than just collecting the data or copying the data from somewhere. It could also include digitizing those data if the data is not in digital form, or it could mean collecting the data, going out there, doing the surveys or whatever we need to do to collect those data. So that's the entire data acquisition part. And for those in data realm, the focus isn't necessarily on the initial stages, like setting up the sensors or setting the survey. So in a data analyst, you probably would not be concerned about, okay, how would I conduct this survey, or how would I install this sensor so that I can start getting the data. But again, it's your job to identify that, okay, we actually don't have this data and this is the way we can get it. And maybe you won't be involved in the actual gathering process, but it will be your responsibility to guide them in the right direction, saying, this is the data we need, this is how we will get it. So once they have installed the sensor, once they have done the surveys and the data comes back, that's when you will start. And then, okay, now I have got this data, I will move it to somewhere else, or I will move it to this place so that I can do my analysis there and I will reach a conclusion. So while a data professional might not be front lines of the raw data collection, they play a pivotal role in ensuring that the data is primed and ready for meaningful analysis. So like I said, the data analyst might not be involved directly in those surveys or data collection, but they need to be aware of the process in that survey and data collection. Because the process of that survey or the methodology that was followed in that surveys will impact your analysis. For example, let's take the same example we've been taking yesterday, where we were trying to find the average income of all Australians. What we usually do is we take a sample. So maybe we will go out there and ask maybe 100 people what their annual salary is. And then we will take an average of that to calculate an rough estimate of what the salary of all Australian looks like. And that process of getting to 100 people and asking them their annual income, that will be the survey. So someone will actually go out on the field and they will do that survey, and then they will give you the data. And now you as a data analyst, maybe doing that average to find out, okay, this is the average annual income of all Australia because we tried to take a sample. But if the sample was not taken correctly, for example, instead of taking samples from all of the state, maybe they just took the sample from maybe Sydney. Would that be a proper representative of the annual income of the entire nation? Maybe not, because all the sample was just from Sydney. So maybe that is a good representation of average income in Sydney, but that's not an average representation of average income in whole Australia. There was nothing wrong with the data. There was something different with the way the samples were taken. And if you were unaware that how the samples were taken, then you would safely just assume that, okay, this is the average annual income of the entire nation, while in reality, it wasn't, because the sample had some bias. Instead of trying to cover wide ranges of suburb, if the sample was only taken from maybe relatively wealthy suburb, then the average annual income might come out a little bit higher. Right? So all those things and all those biases can arise from the data generation point itself. So we need to be aware of those kind of things, and we need to be aware that these kind of biases can exist. So as far as possible, when you're dealing with data, it's also good to understand how that data was generated, because that could have a really big impact on what the final output of the analysis could be. Right? So that's something we always need to keep in mind. And there are a lot of statistical tools and methodologies to define how the sample needs to be taken and how can we make sure that there is no biases in that sample, because getting the data from the entire population is always impossible. So we always rely on the data collected from the samples. So there are lots and lots of statistical tools and methods to make sure that the sample is unbiased. And we learn all about this and sampling and biases and all those things in our statistics session later on anyway. But I just wanted to give you the context that why understanding this data gathering and data collection process is important is, even though the data seems right, if it was not collected correctly, then it will still lead to wrong assumptions or wrong conclusions. And that's something we need to be really careful about. Okay, that was mostly on the collection side. Talk about now the actual acquisition. So let's now assume that the data exists, and now we are trying to get the data to us. One of the most common data types, or one of the most common way of transferring the data you will see in the workplace, is flat files. Files like CSV or Excel file or text file is a pretty common ways of transferring the data. You want all the invoices from last financial year, your finance team will probably send you in a spreadsheet. You want all the candidates who have hired from last year, the HR team will send you an Excel spreadsheet. So that's a really common pattern that most of the time when you need some data, if the data volume is small, you will most probably get it in CSV or Excel because it's human readable, because it's a text file and it's like easy to understand. And a lot of the tools work with it really well. So if you have got a CSV file, you can just double click, then it will open on in Excel and you can easily edit and modify whatever you want in there. So it's really convenient. Even if you look at the file itself, even if you open CSV in a text editor, you can easily see that, okay, there is this column name, there is a comma, and then there is another column name, there is a comma, another column name. And then on the next row, there are all the values, comma values. So you can literally have a look at that file and read what's in there. So that's why it is one of the most common file type, most common data acquisition type that, when you look for data, you will find a lot of these kind of CSV files. And we can have a look at some of the data sources that we can publicly find, like data WA. So I can have a look at what sort of data is available publicly available from the WA government. You can see there are lots and lots of data available. So if I want to have a look at one of these, for example, finance management, it is probably available as an Excel file. So this is saying that this is an Excel file. So an Excel file or a CSV file is pretty common data type, file type that you will get when you're looking for data. So you can just download it and it will download as an Excel file, and you know how to open an Excel file. So let's try download, and I have downloaded that. And now I can open it on Excel. So that was one of the data acquisition process. So when things are in Excel, it's pretty easy. You can understand what the columns are, what the rows are, and you can immediately start to do your analysis. So there are a few tabs as well, so that they can have multiple tables. But that's an example of data acquisition using those kind of flat files. And some of the advantages of the flat file is it is user friendly because we can easily read it, and we can edit it with standard softwares like Excel or any other spreadsheet. And it's universally compatible. So most of the tools will support these kind of files natively. So you don't need to worry about how do I open this file in this tool or that tool. So Excel can easily open it. You can open it in Power BI, obviously. Even a lot of database tools allow you to import Excel files. So you can just click on it and then you can import those Excel files and create a table in databases as well. So it's really universally, really easy to work with, and all the tools are compatible with these kind of files. But the limitation of this kind of flat file is that they cannot encapsulate certain metadata. And it depends from file type to file type. For example, if we're talking about an Excel file, it can retain some metadata. So what kind of metadata we're talking about here is we're talking about data type. For example, if I click on this column, it is saying me that this is of data type number, because this is a number, right? This is the metadata about this data. We have got this data itself, but there is an extra information about it saying this data is actually a number. So this 2.5 is a number, but for some reason, the final column, it's also a number. For some reason, this column is coming out as a text. And that's probably a wrong metadata here, because this was supposed to be a number as well. But now you get the point that there will be data itself, but we also need some metadata about that data saying what this data is. It could be a number, maybe it's a currency. Then you can also say that, okay, so it's not a number, it's actually a currency. So you can store that extra metadata about the data so that when you share this data with someone, they will also have that context and say, okay, this number actually is not just a number, it's actually a currency. So it's a dollar value. So they will probably apply whatever transformations or whatever calculation they need to do for a dollar value. But if it is a number, maybe they will do some different kind of calculation on it. Right? So that kind of metadata are stored in some of the files. For example, in Excel file, it can be stored, but in other files like CSV, we cannot store that metadata. And that's one of the limitations of these kind of file types is you lose that metadata. So you get the number like 2.5, but there is no metadata saying that this is a currency. So you have to assume yourself that, okay, yeah, this looks like a number, so I'll just treat it as a number, but you won't know whether there was a currency or whether that was a percentage value or whatever it was. So that kind of metadata can be lost, and that's one of the limitations of flat files. If your file size grows, then it can be really inefficient to process and analyze. So if you start getting into millions or multi-million rows, then you cannot work with flat files. Excel itself has got a limitation of 1 million rows. So you cannot analyze a data with more than 1 million rows in Excel. And even when you go to maybe like 200, 300,000, it starts to slow down really quickly. So it's not really built for those kind of high volumes. Next is semi-structured. So instead of flat files, there can be some semi-structured files. Semi-structured files can store a lot of additional metadata because they do not need to follow a strict structure. That's why you can pretty much store anything in these kind of files. You can have references to other paths in your file and things like that. So these are, again, pretty common data acquisition formats. And most of the time, these kind of JSONs are used to transfer metadata about the data. So most of the time, you probably won't get data in JSON unless you are maybe doing some APIs, and that will definitely return your data in JSON file. But yeah, other than that, these kind of JSONs and XML are used for configuration or metadata management. And I will show you an example of how a JSON data acquisition would look like. So if we search here, so if I location, if I search for JSON, then yeah, there is JSON data as well that are available, and mostly JSON data are available. So when you make an API call, and we learn about API calls in a little bit now. But when you make an API call, which is just let's talk about API now. So this is how a JSON file looks like. This is a very huge JSON file. So what a JSON file has is it will have a key and it will have a value. I think this is not readable for you guys. So zoom in a little bit. So a JSON file is just a key and value. So that looks like a timestamp. That's the device ID. There's no data. Timestamp. Oh, there you go. Data is the barometric pressure and relative humidity. And there is air temperature as well. So that's one entry. And within that entry, there are keys and values. So that was the timestamp. That was the air temperature at that time. That was the barometric pressure at that time. And that was the relative humidity at that time. If we compare it to CSV, it's similar, but every time we have a value, it will duplicate the key as well. They will always appear in key value. So if we need to find temperature, we can always look for air temperature. And then next to that will be the actual value. So we do talk about these kind of API calls a little bit later in today's session. So I will just skip through it for now. So they can store additional information, and they can also have complex hierarchies, because in Excel file or CSV, you only have rows and column. Like it cannot have like nestings. You cannot have references to other block of data or anything like that. But in JSON, we can actually have those kind of complex hierarchies and saying this value is a child of this value and a child of this value. So we can have those kind of hierarchical relationship in JSON. And that's one of the reasons why JSON is quite popular in most the API calls and websites and things like that. One of the problem with JSON files or semi-structured data is there will be a lot of redundant data. And if we look at this one, we already know that, because, for example, every key is repeated over and over again, which is quite unnecessary if you think about it. If we know that was the timestamp, then if we put it in this certain place every single time, we don't have to call it local timestamp every time. Every character takes up space, right? So every character, when you're storing it in your computer, it takes up space. And if you are repeating that character a million times, that's a lot of space wasted. So that's one of the limitations of these kind of data types. But what it does allow is, because we're repeating this so much, it allows us to be flexible. For example, in this sensor, if I have a new reading in here called dew point, let's say, for example, then I can simply add that dew point in here and the value is 4.0 or whatever. And it won't break anything, because this is a semi-structured data. The structure is not enforced. We can always add any new key value here to our JSON and it will still be okay. And that's one of the advantages, that it makes it flexible, but at the cost of a lot of those repetition. So depending on whether you want to be more flexible or do you want to be more frugal on the storage side, you can decide, do you want to go with semi-structure or do you want to go with fully structured so that you save those memory spaces? And again, we have got the data storage part as well, where we talk about those memory spaces in depth as well. So we talked about flat files and semi-structure. Both of them were just text files. There were nothing fancy about it, just a text file with a bunch of data on it. But let's move on to slightly sophisticated data acquisitions, which are relational database queries. And this is quite common when you're working in an organization. Most of the data, when big amount of data, you will find it living in a database. And the way to get data out of the database is by running SQL queries or the structured query language. Depending on what database they are using, the SQL query might be slightly different, but there are certain standards on SQL to make sure that all the databases have similar syntaxes. For example, if you select something from a table, it will work on all the SQL databases. And what this does, it gives us the flexibility on selecting what we want. So in CSV or Excel, because it's a complete file, you either get the whole file or you don't get anything. There is no in between. You cannot send half the file. It cannot happen. But with databases, because you are the one making the query, you can decide what you want and what you don't want. So for example, yes, I want something from this table. Let's say that was a sales history table. Then yes, I want the sales history, but I want the sales history of last week only. And that's the flexibility with database is you get to select what you want from it. You can actually join multiple tables and then you can select, okay, do this and this calculation and just give me the final output. And then you can just extract that final output from there. And what this does is it saves you from a lot of overheads like, okay, I need to get all of this data out. I need to do analysis somewhere else. It prevents you from that. So you can do all those manipulations on the SQL itself and just get the output that you need from that. So one of the examples that could be is, let's say we have got this SQL database where we have got all the jobs listed on Seek. Okay, so this is stored in our database. So we can see this table is huge. It has got a couple thousand jobs. But what I'm interested in is I want to do a count of how many jobs are available in different states. And I want to also categorize them by job types. For example, I want to know how many full-time jobs are available in Sydney, how many full-time jobs are available in Perth, and things like that. So for that use case, one way I can do it is I can extract this entire table and I can do that analysis myself. But because this is SQL, I can actually write the query myself. I can tell the database the calculation that I want to do, and I can only extract the output of that calculation. And that's what I'm doing here. What I'm doing here is, okay, I want to count the number of jobs available by work type, which gives me the full-time, part-time, or casual, and the search location, which gives me the state. So count the number of jobs available by these two categories, but I only want to have a look at the job, which has a search date of 7/6, which means that was the time the job was available. So any job that was available yesterday, I want to do the count and I want to see which location has got the maximum amount of full-time job or part-time job. And I can even do order by to make sure that the location with the highest job count will come on the top, because maybe I'm just only interested in the top 5 location where they have got most job. So I can order by to make sure that the highest count comes on the top. So if I do that, then the output will be something like this. So Sydney has got 2,466 full-time jobs. And then Sydney also has got 580 contract or temporary jobs. So now I can start my analysis from this rather than the entire table. Instead of having all those 10,000 job records, if you're only interested in the count of the jobs, you can just write the SQL, let the database do its job, and get the output and do the further analysis from there. And again, all this kind of SQL that we're writing, you learn all about this SQL and how to write this kind of SQL in our SQL class. But I just wanted to show you the data acquisition technique from the SQL. If the data is living in a database, how would we extract it? Yeah, there is a way that you can just extract all the data from the database, but that probably is not efficient. If you're just interested in solid analysis, you can write your SQL query to do that analysis and just give you the output rather than pulling all the data out and doing the analysis on your own. So that's on the relational database query. Okay. So when the data is in database, it's well structured, it's organized in tables. So getting the data out is really efficient. And it's even efficient if you do the analysis on the database itself. If I extracted all of that data out and I was trying to do the count on my own, it would take some time because it has to process it and all those things. But when I did it in the database itself, because database is optimized to do those kind of things, it didn't even take a second to give me those counts. So it's really quick. And obviously the databases comes with security. So if you want to protect your data from accidental deletes or malicious access, then obviously database can help you with proper security. You can even put security at a role. So if you have got the same table, for example, let's say we have got an employee table, and maybe the company policy could be that, okay, as a manager, you can only see your employees, not anyone else. So you can even have that level of granular control in the databases. But if we talk about the same in the other one, like flat files and JSON is also a file, you cannot have that kind of security. Those files will be like, yeah, whether you have access to that file or not. You cannot decide, okay, you have access to half of the file. It doesn't work that way. And connectivity. So connectivity could be the issue, but once you have sorted the connectivity, it's always good. So you need to be able to connect to the database. And once you have connected to the database, you can run your queries and you would get the output. So that's on getting the data from relational databases. And the fourth one is application programming interface or APIs. So APIs are the mediator between the server and your application. So the way API works, or the way the entire web works, is when you go to any website, for example, again, let's take this example, seek.com. What is actually happening is your browser is actually making an API call to Seek's server. Okay, so Seek's server is here, your browser is here. So when you go to seek.com, your browser is going to Seek's server and asking it, okay, this person wants to get to your homepage. What are the things I need to show in? And then the Seek server will give that all the content that you see in here. These are the things you need to show to that user if they come to our homepage. And that's what we're seeing here. If we inspect here, so we can see all of that happening if we go here. When we go to this website, what's happening on the background is our browser is doing all these things, which is it's going to Seek server, seek.com server. It's talking to the server and then saying that, okay, this person wants to go to our homepage. What do I show them? Or what are the content for that homepage? And then the Seek server returns something on that request. So it's called a GET request. So it's a request to get something. And the server responds with something. So it gives you a JSON file. It can give you text file, whatever it is. And then it will get back to your browser. And that's what gets displayed on your browser. And for example, if we just say, okay, I want data analyst for all Australia, we can see how this thing works. So I want to see data analyst role for all Australian. And if I click this button, something will happen here. A lot of things happen. So it probably won't be always just one API call. There can be multiple API calls as well. And what we can find is there are lots of API calls which we probably are not much interested in. But what we probably are interested in is this API call maybe. Yeah. So this API call was made to seek.com.au/API. So that was the API the website was calling. And this is what it got in response. And this is a JSON response. So this is what the API returned to our browser. So it's saying that in data scientist, there are 1412 jobs. In junior data analyst, there are 294 jobs. In business analyst, there are 6577 jobs. And then in data, there are 4744 jobs. So it's showing all those related jobs in here. And in here, this other API, this is where the actual content is being returned. So for this medlog, you can see this medlog Australia, and then you can see Fremantle and Southern Suburb, Fremantle, Perth. I think this is the one. What is it saying? Iconic Fremantle building. Yeah, iconic Fremantle building, support team, growing organization. See? So what happened in the background was our browser made an API call to the server, and then the 6th server gave our browser this JSON back. Based on all the logic they have in this sig.com, they have JavaScript and whatever running in here. They converted this JSON into this nice readable format. So in API terms, what did happen is we made a call to the 6th API. The 6th API returned us a JSON file. And from data perspective, that's the only thing we need to worry about. We don't need to worry about how this JSON got converted into this nice looking thing. We don't care about that because we're not front-end designers. What we care about is how we can make these kind of API calls and get this JSON in response. And this JSON is our data. And that data we can start to do some analysis on. This database was actually created by doing those kind of API calls. So I did those kind of API calls. I got the JSON as response, and then I converted it into table, and then I saved those tables in this database. And that's like a typical workflow of those API-based data ingestion would look like. So you hit about API, it will, most of the time, will give you a JSON response. Now you need to know how to convert that JSON response into a table so that you can start to do your analysis in the tabular form. Because most of the analysis usually are done once your data is in tabular form. So you will take any other form of data and you will try to convert it into tabular form. And again, don't worry about how you will convert JSON into a tabular form. We also learn about that in our Python session. So I will show you how you can convert this thing into a nice looking table. And once things are in the table, you can do whatever analysis you want to do. After that, you can use Excel, Power, whatever tool you are comfortable with to do your analysis. And the reason I'm talking about all this is because when you go into a data analyst interview and you get asked, okay, what sort of data you have worked with? Or where have you got your data from? Do you know different ways of getting the data from different systems? Then again, if you come straight from university and even you went to become a data analyst in university, they will never teach you about these different kind of data acquisition things. In the university, when you work on your project or when you work on your lab, you will always just work with these flat files, which is CSVs, Excel, and you never know all these other different kind of data acquisition techniques that exist. And when you go to an interview and then they ask you, okay, what sort of different data acquisition you have used? And you would be like, yeah, I always use CSV or Excel file. And they will be like, yeah, but haven't you heard about all these different data acquisition types? And that could be a red flag. So if you can tell them that, yeah, I know I mostly work with CSV and Excel, but I also tried doing some SQL queries to get data out of the SQL databases. I also tried to work with some of the APIs to get the responses and work with that data. And that will make a really good impression, and they will understand that, okay, this person knows what they're talking about, or this person is maybe well versed in, at least in the data acquisition part. Because in the workplace, not always you will get the data from Excel or CSV. You will definitely need to get some data from databases. It maybe APIs not so common, but yeah, it's a good skill to have that you can say that, yes, I can make an API call and get the data from APIs as well, or I have done that in the past. So it's a nice to have, maybe APIs one, but yeah, definitely the relational databases, being able to run SQL queries and getting the data. There are a couple others as well. So cloud object storage, again, it's actually nothing different from, like, you can compare it to your own computer storage. So in your computer, your files are on your computer. But when you have to store huge amount of files, like terabytes or even petabytes, it doesn't fit on your computer anymore. So where do you put that data? In cloud? And in cloud, there is something called object storage, which is just a fancy way of saying a storage in a cloud. It's nothing more than that. So you take your files, you dump it in the cloud. That's the cloud object storage. Nothing fancy in there. But what we tend to do in cloud object storage is we tend to use some more efficient formats in the cloud object storage. So instead of using CSVs and Excel, we probably will be using Parquet or Avro or quite efficient storage formats to increase the efficiency. Okay. Again, you probably don't need to worry about what these formats means, but you need to know that the cloud object storage exists. And if you get a question in the interview saying, we have got a petabyte data. What do you think do we need to store it? And then you'd be like, okay, I don't know. I have never seen petabyte storage data. But yeah, instead of that, you can say, okay, we can store it in cloud object storage. We can probably put in a good compression algorithm on it or put a efficient storage format so that size gets reduced as well. So if you just tell, that will change the dynamics there. And the next up is data warehouse. Data warehouse is the combination of your cloud object storage and your relational database. So relational database also has got some limitations, like you cannot store really large volume data on it. And the other thing is on most of the relational database, it's hard to run analytical queries. So you maybe want to run a query to analyze purchase history for the past 5 years. In traditional relational database, it's hard to run that query because those kind of databases are not optimized to run that kind of workload. As a data analyst, I will be interested in looking at those historical trends. I will be interested in using as much data as possible to train my machine learning model. So I would want to run those big queries. So what do I do then? If the database cannot run those big queries, am I out of luck? Obviously not. There are solutions for that. And that's where the data warehouses comes in. So data warehouses is a large scale data storage and analysis engine. Okay. So it's the combination of storage and your SQL databases. So for data analyst, because again, as a data analyst, you don't need to worry too much about how the data warehouses operate, but you as a data analyst needs to know how to use those data warehouses. So the data exists in a data warehouse. How do you run your analysis, or how do you get the data out of there for your analysis? And most of the modern data warehouses have a familiar SQL interface. So sometimes you won't even know whether it's a data warehouse or a database because you don't care. For you, it's just a SQL that you write a SQL and something happens and you get the data. So most of the time it will be like that. Yeah, you don't care whether it's a data warehouse or a SQL database. You will just write a SQL and you get the output. But it's good to know that, for really large scale data, not even the SQL databases, it's the data warehouses that comes into play. Okay, so those are the different data acquisition types. You can revisit just flat files, semi-structured, relational databases, APIs, cloud object storage, and data warehouses. Now let's move on to things to look out during data acquisition phase. Now let's talk about what are the things we need to look out for while we are getting the data. And this is really important because if you don't get the right data, your analysis won't be any good. So finding the right data is important. So always be aware of where the data is coming from. This will help you understand how it was collected, because that can have a massive impact on your analysis. So always try to find that if you can. And additionally, it is important to document the data lineage properly so that you know exactly where each piece of data is coming from. And sometimes, like most of the time, you won't be working with one data alone. You probably will be working with a lot of different data coming from a lot of different sources. And when you are dealing with a lot of different sources of data coming from lots of different places, you need to have a documentation, and it's called the data lineage document. For example, this data is coming from ADS. This data is coming from data WA. This data is coming from somewhere else. You have to have a proper documentation of that lineage so that obviously it helps you in the first place, but it could help other people's take over your project, or it will help other people do the audits. It have to audit your work as well, right? Because a lot of the time, if you work in governments and like a lot of other regulatory organizations, your work needs to be auditable. Because sometimes maybe some decisions were made based on your recommendation, but maybe that didn't turn out well. So what will happen? There will be a formal audit. And then if you don't have these kind of data lineage documents, they cannot do that audit because no one knows where that data come from. Even you will forget it after some time that where that data came from in the first place. So that's why finding the right data source and finding out how the data was collected is important, but it is equally important to document where the data come from, how it was collected, and all those information about it. Next up is data quality. And I think I have talked too much about data quality at this point. So you already know how important data quality is. The analysis you perform can be only as good as your data. So do the data quality test as soon as you can, so that if you know that this data does not meet the quality, don't use that data. Try to find some other data if you can, instead of waiting till the last minute to see whether I can work with this data or not. Do that data quality check early on to make sure that this data is not worth exploring because this is really poor quality and I cannot do with it. So I do that data quality test as soon as you can and address them before they become a problem. And the other one is data provenance. So data provenance is also crucial when it comes to data acquisition. Make sure to capture and preserve the important information such as data type, source, and time of collection, as well as time data processing. Okay, so when you are doing the transformation as you go, you need to keep track of what you're doing. For example, you started analyzing the data, you found some nulls in some of the columns, and you decided to drop those nulls. But maybe you forgot to document that. And then what would happen is after a while, you would even forget that you dropped those nulls, but maybe later you realize that your analysis is wrong because you're not supposed to drop those nulls. Or maybe those nulls were something meaningful like the sensor going down or whatever it was. And your analysis was trying to find out how many times the sensors are going down or anything like that. And now you don't have that data because you dropped them. Right? So it's really important to take a note of those steps as well. Okay, we got the data from this point. We converted this into this data type. We took out the nulls from this column. We did something else. We did the summary on this column. We did the pivot on that column, whatever transformations. It's good. It's always good to take a note of all those steps so that obviously it helps yourself to go back and fix anything if there is any problem. Or like I said, the other one is more about the auditability. If someone needs to audit your work, they will have that proper data to see, okay, the data from this point, they did this transformation and they can check every step. And more than that, it can also help you with transferring your work to other colleagues, right? Because it's always a teamwork. You won't be working alone, right? So you probably are working with a team, or you probably need to hand over your work to some other team, and then they can look at this data provenance document and they exactly know how the data was transformed, where it came from, all those things. Frequency of data acquisition. So finally, it's important to consider the frequency of data acquisition and make sure to match the frequency of data collection to the reporting requirements. At the end of your analysis, there will be the final outcome. The final outcome might be your dashboard. The final outcome might be your report. Or maybe that's an email that you send out to someone by the end of the month, so that there is an output or output of your analysis. And depending on the frequency of that analysis, you need to create the frequency of the data acquisition, right? So if the final output that you're going to produce, if it is only needed every end of the month, then there is no point in getting the new data again and again until the end of the month, because the final output is not going to change anyway. Or if that final product is needed every week, but if your data doesn't come in every week, then that's not going to work either, because you are sending out your output today, but you are getting the new data tomorrow. that doesn't make sense, right? Because that new data will be missed in this report, and maybe they are expecting that data in this report. So try to think of what the frequency of your final product is, and that will dictate what the frequency of your data acquisition will be. Because the goal of getting the data is to cater for that final product. So always make sure that we have got the right data at the right time to produce that final report or final product, whatever it might be. And the other one is minimize manual intervention. So in this data acquisition stage, there can be manual intervention. Maybe the data doesn't come automatically to you. Maybe someone needs to do something and then they will send it to you manually, which is okay for lower frequency data. If you need an extract from finance every month, it's probably fine. Someone from finance can do that extract for you and send you the data. But it's always good to reduce that manual intervention as much as possible, because humans are error prone. You will probably type something wrong. There are thousands of ways things can go wrong when we are doing it manually. So where possible, try to eliminate that manual intervention. Try to automate the process and say, okay, instead of you sending me the export, why don't I run the SQL query myself on the database and get the extract? Or why don't my report itself or my Power BI connects directly to the database and gets the data when it needs it? That's even better, right? Because there is no human intervention now. And then it will be always up to date as well. So it fixes the frequency problem as well. Because if we rely on manual intervention and your report is supposed to go out on Friday, but the people from the finance didn't give you the data until Monday, then you have a frequency problem. But if you eliminate that manual intervention, you solve that frequency problem as well, because now it's automated. So the report can get the data when it needs automatically from the database. So minimizing the manual intervention not only helps prevent the errors, it will also help with the frequency problem as well, so that the data is always up to date because it's all automated. And the next one after that is acquire only essential data. And this is really important. And you need to apply in your workplace as well when you're working as a data analyst. So when you are doing an analysis, there will be data that you need and there will be data that you don't need. And always only acquire the data that you need, because that's the best way to comply with those regulations and make sure that you're not breaching any privacy or any confidentiality policies. For instance, let's say you want to do customer segmentation and you want to have a look at what items customers are buying, and you want to maybe segment those customers into different categories. So for that, analysts, you will probably need the customer ID or something identified to that. You will need what they bought, when they bought. And you probably need a few other criteria like where they live, what's their most frequent store, and those kind of things. But for that analysis, would you need their emails? No, we definitely don't need, because the email doesn't help us with any of them. An email is actually confidential or personal information. And as soon as you touch the email, all of your analysis becomes sensitive now, because you have got emails in your analysis. But that was not your end goal. Your end goal was to just segment the customer, which you could have done without the emails as well. So what you do is you leave out the emails in your data acquisition process. You say, I don't need emails. I only need this and this. And because all these are not personal information, so my analysis now doesn't become a personal or sense. It's just maybe an internal analysis now. We don't have that personal. So it's really good to know what you need and what you don't need. And you make sure that you don't import unnecessary things, or you don't use unnecessary data to complicate your situation. As soon as you touch that email, your whole analysis becomes sensitive, and you probably have a few more regulations here. And that leads us to regulations. Right? So whatever you're doing, any data related things, you need to get to regulations. For example, like in this publicly available data, that's fine, because this is already public. available. So any analysis you do on this data be public. Is think about this is already publicly available. But once you get into an organization, then you get into all those realms of saying, okay, this data is sensitive, this data is confidential, this data is highly confidential. And as a data analyst, you will have a lot of created privilege and have access to a lot of sensitive or highly sensitive or confidential data. So now you need to know what organization policy is really organization. And sometimes there will be instances where you cannot even share the data with your colleagues. Yeah, your colleague is probably a data analyst as well. You are a data analyst in the same company, but maybe you're working in a project which has got access to this highly confidential data, but your colleague might not be. So you cannot even share it to the colleague. Just because your colleague working in the same company doesn't mean you have the same privileges. So the good rule of thumb will be don't share the data or don't share the analysis before you know whether that person or whether that entity has proper privilege to have access to that data and the analysis. So that's on the things to look out. So we talked about finding the right data source, making sure the data is of good quality, making sure we document all of our steps using data provenance document, figuring out what the frequency of data acquisition is required based on what our end product is. And we also talked about minimizing manual interventions. We talked about why we need to eliminate humans from the process. That doesn't mean we replace them with AI. We just replace them with automation. Acquire only essential data. So leave out the data that you don't need for analysis because that can just introduce unnecessary overheads. Only acquire the data that you absolutely need for your analysis. And obviously adhere to the regulations. Let's talk about the importance of choosing your data acquisition method wisely. So the choices made the data acquisition phase can significantly influence the outcome of the entire analysis. Because if you got good data in this process, analysis will be good. If you got bad data in the process, your analysis will be bad. This is why it's crucial to think through the data acquisition choices. Obviously, acquiring good quality data. The primary objective is to obtain the highest quality data possible. Yes, so always prioritize reliability and accuracy in your data acquisition. And always try to look for more sustainable and reliable sources. For instance, don't rely on someone sending you the data or you manually downloading it from somewhere and try that. Where possible, try to get more reliable sources, like whether it's a SQL database and API calls are pretty reliable. Try to find more reliable sources where possible. And setting clear requirements, it's about, you need to be clear about what are the analysis that you want to do and what is the data that you need and what is the data that you don't need. And also on the frequency, on how frequently you need that data. If the reporting only needs to happen at the end of the month, there is no point in getting the data and replacing for every day because every incurs in cost. So when we are talking about cloud cost or even compute cost or even human resources cost, because if you're trying to replace that data over and over again, it's probably taking up your time. But if that final output was only needed by the end of the month, then we're wasting a lot of time and resources here by just trying to repress it more. So try to keep that requirements clear, and that will help you on choosing the right data acquisition method as well. And where possible, again, leverage the modern data acquisition methods like APIs and database APIs are pretty reliable, and you should try to go towards either API based or direct connection to databases to get the data where possible. So that's on data acquisition. We'll move on to data storage a little bit later.